So, welcome to our today's session. So, in the previous class, we discussed about the concept of spheres touching coordinate planes and also axes. So, could you recollect that concept once and the equation what we have written there when a sphere touched by the three coordinate planes and also the three coordinate axes, how the equation comes? Please take a note of that, which is given in the previous class. Right. Now, let us take our today's problem. The problem is given that a sphere is inscribed in the tetrahedron whose faces are just give me a moment. So this is the problem. So please take a note of that. After noting, please tell. So if you understand that you are inserting a sphere in a tetrahedron, so for our visualization, if you just understand the case of a pyramid, on the top you have three faces and in the bottom you have one face. You feel that it's a triangular pyramid. You have three faces on the top, bottom is also one face. So you can visualize that the three faces are nothing but the equations x equal to 0, y equal to 0 and z equal to 0. Hence they are nothing but the coordinate planes, say yz plane, zx plane and xy plane. And the bottom face you can take it as the other plane equation. Then you need to calculate what could be the equation of the sphere. Okay? Is the thought process clear to all? Any doubts to anyone? So obviously, when you are inserting means the sphere touches the inner faces of the tetrahedron. It is just like keeping a sphere in a box so that it is exactly fitted in that box. So you can feel that the sphere touches the three coordinate planes. So obviously the equation of the sphere you can take it as x square plus y square plus z square. Then you have the other equations So do we accept the equation? So since for a particular D, we are taking the 8 things, please understand. So if you take the positive side of it, let me say one thing, why I am taking minus there. There is one more face which is given there, right? One more plane, 2x plus 6y plus 3z equal to 14. So let us make it in the intercept form. Then what happens? Obviously you have accepted the intercept form. Since the values are positive, obviously you should take negative sign there, because earlier you have written a speed equation having intercepts where the minus sign comes. Could you recollect that in the beginning of the speed equations? That's why I have taken minus there. So here it is nothing but 2 into root of d by 2. Right. Now the thing is, what could be the possibility of that one? The possibility of root of d by 2. Can you guess? So from this thing you can say that this plane making intercepts on the axis as 700, 0, 7 by 3, 0 and 0, 0, 14 by 3. Accepted? So if you consider the axis, this is one point, this is one point, this is the other point. So since the plane is making intercepts, the sphere must fit inside of it, the intercepts part. Agreed? Are you getting the thought or not? So that what happens, the value of root d by 2 must be smaller among the 3 values, because you have 3 different numbers are there. Otherwise, if the value of root d by 2 exceeds one of the things, then the sphere will not insert there. So we have to take that root d by 2 value should be less than smaller among the 3 intercepts. So among the 3 intercepts, which number is small? One number is d, one is 7 by 3, one is 14 by 3. Right? 7, 7 by 3, 14 by 3. Among the 3 things, which one is small? 7 by 3, isn't it? Yes or no? So root d by 2 must be value less than 7 by 3. So that was the class here. So this is our required equation of the sphere. If you are able to determine what is d, then you are done. And I have specified a condition that root d by 2 must be less than 7 by 3. Why? Because in order to fit the sphere inside the intercepts, because the fourth plane is making in the bottom the intercepts with the axis. So if you are able to determine d value, then you are done. Okay? Any questions for anybody up to this part? Please take a note of that. Now if you calculate the center for the sphere, then it is nothing but and the radius part you can calculate, that is also nothing but root of d by 2. Because if you simplify u square plus v square plus w square minus d, you will get root of d by 2, the radius value. In order to simplify, let us take a symbol that, let us take k is equal to root of d by 2 for our convenience. Now, since the sphere is inscribed, it is touching the faces of the tetrahedron. So it will touch xy plane, yz plane, zx plane, and also this plane. So as and when a sphere touches a plane, what is the condition? Distance equal to radius. Agreed? So let us apply the condition that distance is equal to radius here. So you are calculating distance from center of the sphere to plane. Since I have taken root d by 2 is equal to k, for convenience, it is 2k plus 6k plus 3k minus 14 modulus by square root of 4 plus 36 plus 9 is equal to k, radius value. So if you simplify this part, 11k minus 14 modulus is equal to 7k. You can go for squaring on both sides, which gives that 18k square minus 77k plus 49 equal to 0. Giving that k is equal to 7 by 9 comma 7 by 2. Now you have achieved two values for k, among which I am taking only 7 by 9. Why? Because you have given a condition that root d by 2 value must be less than 7 by 3. Because in other words, root d by 2 is nothing but the intercepts made by the sphere on the axis. So you have two things here. Plane is making intercepts on the axis. Sphere is also making intercepts on the axis. So in order to fit a sphere in the plane, the tetrahedron type, so these intercepts must be less than the plane intercepts were made. That's why root d by 2 must be less than 7 by 3. So among the two values, which we consider as 7 by 9 because it is less than 7 by 3. So by substituting in place of this 7 by 9, which is our required answer. That's it. Okay. Any confusion or any questions for anybody? Is the approach clear to everyone? If you are clear, then I take the other question. After making a note, please inform. So the next one is show that the spheres So here I have given two sphere equations. I have to show that the two spheres touch externally, and since whenever they touch you just have one point as common to them, so we have to calculate the point of contact. So for a small visualization you can have the picture like this. So in order to show that they touch externally, what could be the condition we need to check here? Any guesses? So if you can say this is the center of the first sphere, this is center of the second sphere, then it will be the radius of the first one and this will be the radius of the second one. Accepted? So distance between the centers must be equal to sum of their radii. So distance between the two centers must be equal to sum of their radii. That condition we should check. Hence we can be able to say that they will touch externally. So for the first sphere, the center is 1, 2, 3, and the second sphere 5, -1, 9. These are the centers. So if you calculate the distance between them, it is nothing but 13. Accepted? Applying square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, you will get 13 for the 2 points. Accepted? Please check on that. And the radius for them is nothing but, for the first sphere radius is equal to 8, for the second sphere radius is equal to 5. Please do and confirm. Hence this condition is satisfied here. Any doubts for anyone? Right. Since this condition is satisfied, they touch externally, we need to calculate the point of contact. So if you say the point P of x1, y1, z1 is the point of contact, Then how can we calculate that? Is there any known formula there to calculate the point of contact earlier? So one interesting thing is, whenever they touch externally, the point of contact divides the line segment internally. Agreed? The point of contact divides the line segment joining the centers internally. In what ratio? In the ratio of their radii, 8:5. Agreed? Say yes or no? So whenever you know a point divides a line segment internally, you have the formula that so could you recollect the formula for finding the point of contact? So where if you say that x1, y1, z1 or xyz is the point of contact, then this is one center x1, y1, z1, this is the other center x2, y2, z2. Applying the ratio m:n is equal to 8:5, you will get the point of contact. Please check that. So by applying the formula, you will get the point of contact as 45/13, 2/13 and minus 57/13. So please confirm the answer. So if you have noted this, then I take the other problem. If you have any other queries, you can ask. You are saying this one, the value, yeah. So what is the value by the calculation? Is it minus 57/13 or something? Yeah, 87/13, right? Right. Done. All right. Then we take the other one. Now, let us take some formal definitions, which will be interesting. Then we start discussing about the problems. We know that whenever two spheres intersect, we will get a circle. Now, if you want to calculate the angle between them, if there is a common point P between the spheres, let me say this is the point P in which the two spheres intersect. So I want to know what is the angle here. So how do we calculate that? At the point P, we consider the tangent planes here. Therefore, the angle between the planes is nothing but the angle between the spheres. And if you say that theta is the angle, then the formula for cos theta is given by r1 square plus r2 square minus d square by 2 r1 r2. So please take a note of this formula. Now what happens if the two spheres intersect orthogonally? In other words, the angle at this point is nothing but 90 degrees. So in such case, what happens? If you observe that this is sphere 1 and this is sphere 2, at this point you have 90 degrees. Then if you say that these are nothing but the centers, then you will get a right angle triangle here. So this is the thing actually you will get. So are you getting the idea here? So whenever two spheres intersect, then this is nothing but radius of one sphere, this is nothing but radius of another sphere, and this hypotenuse is nothing but the distance between the centers. Accepted? So using the Pythagoras theorem here, distance between centers whole square equal to radius square plus radius square. This condition we use to check whether two spheres are orthogonal or not. Another thing is, if you write the general equation of the sphere, x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. So if you have considered two spheres, if they intersect orthogonally, then by applying this condition, the result will be reduced as in other words, that was the condition we use for checking the orthogonality. So if you say that u, v, w values taken from the sphere equation, d and d dash are nothing but the constant values in the spheres, then if the condition is satisfied, how the condition came? By simplifying this equation. Distance between centers whole square equal to radius square plus radius square, that will come. So that condition we generally use to check for the orthogonality. So that also you take a note of that. Now generally, whenever two spheres intersect, you will get a circle. So obviously, in this case also, when the two spheres are orthogonal, you will get a circle of intersection here. So for this circle, you will have a radius. So its radius formula is nothing but r1 r2 by square root of r1 square plus r2 square. So this formula we use to calculate the radius of the circle when two spheres intersect orthogonally. That was the condition. So if you have noted clearly, then I go with the other concepts. Right. Now let us take a definition that power of a point so it is nothing but, as you know, whenever a point is given, how to check that whether it is internal point, external point, or a point lying on the sphere, isn't it? Say, how do we calculate? Simply we substitute the point in the sphere. It is nothing but S11, you will get a number. If the point is outside, it is positive. Inside, negative. 0 if the point is on the sphere. Accepted? Now, you consider two spheres. I am saying that you have taken two spheres having different centers. It means that they are not concentric. So if you have taken two different spheres, radius may be equal or different, but you have taken spheres having different centers. Then between them you consider the points whose power is equal. Then the set of all points will define a plane to us. So for the two spheres, you are considering the set of points or the locus of points whose power with respect to the two spheres is equal. Then those points will define a plane to us. That plane we call it as radical plane. So is the definition clear to all? What is meant by radical plane actually? Say. Now, how to calculate radical plane? The definition what I have mentioned, if you take two sphere equation, taking that power is equal means S11 is equal to S11 for two spheres. This is sphere 1, this is sphere 2. Then you will get a plane equation. So it is nothing but the difference of two sphere equations. So whenever two sphere equations are given, you subtract one equation from the other sphere equation. You can take either of the way, S1 minus S2 or S2 minus S1. You can take anything. So the resultant is nothing but a plane, because x square, y square, z square values gets cancelled. You will get an equation in x, y, z. So it is obviously a plane. That plane is nothing but the radical plane. So in order to calculate the radical plane, we need to subtract the two sphere equations. That's all. Fine. Are you clear with this? If you are clear, then I take the other point. The second one is radical line. So what happens? You know that line is nothing but intersection of two planes. So let us consider three sphere equations. The centers are not collinear. Now what happens if you imagine that three spheres are there, the centers are not collinear. Now for the first two planes, for the first two spheres, you consider the radical plane, subtracting them. So you will have a plane equation there. And obviously, for the other two spheres also, either these two or these two, you calculate the radical plane. So suppose you have taken these two or these two, the sphere will come like this, the plane. So this is the radical plane of the first two spheres. This is the radical plane of these two. So these two will intersect. Here you will get a line, the line of intersection. So intersection of radical planes give radical line to us. So in order to determine radical line, we require three sphere equations. And how do we represent the line? Very simple. Subtracting these two, you will get a plane equation. So this is the plane equation. Equal to 0, equal to, subtracting these two, you will get another plane equation. That's all. Okay. So please take a note of that. Then we go for the other concept, that is radical center. So understand that center is nothing but just a point. So in order to determine the radical center, you have to take four spheres. The centers are not coplanar. That means the centers of the four spheres should not belong to a single plane. Now, as we know, to calculate the radical line, we require three spheres. So if you feel that the first three spheres as a set, you will get a line here. Similarly, if you take these three as a set, you will get another line. If you take these three as a set, you will get another line. So like this, you will get four lines. Four radical lines you will get. All the four lines will meet at one point. In other words, the lines are congruent at one point. That point we call it as the radical center. So in order to calculate radical center, it is very simple that you just calculate 4 planes. So by subtracting the 4 speed equations from one from the other, you will get 4 plane equations. These 4 plane equations are congruent at one point. In other words, the intersection of 4 planes is simply one point. That point we are calling it as actually radical center. Okay. Is the definition part clear for everyone? Or any doubts for you have? Please tell. Then let us do some problems here now. If you have noted the definitions. If anybody has any other queries, you can ask with regard to these definitions. All right. Shall we go with radical center straight away? A problem on it, the simple problem. Fine. So here we have to calculate the radical center. For the speed equations given by So please take a note of the 4 equations. After noting, please tell. So we have to calculate the radical center for the 4 speed equations which are given like that. Right. Now let us give the names as first sphere S1, S2, S3 and S4. So finding radical center is nothing but you just need to calculate 4 distinct radical planes. So if you solve the 4 plane equations, nothing but you are finding a point which is common to 4 planes, nothing but the radical center. So the radical plane of S1, S2, the first 2 spheres is nothing but the difference. You simply subtract one sphere from the other. You just go for the subtraction. So if you simplify that, you will get the equation as accepted. You can do S1 minus S2 or S2 minus S1, anything you can do. Agreed? So if you want to calculate radical plane of S1, S3, So what I am doing, I am fixing sphere 1. For the remainings, I am calculating the radical planes. So if you subtract them, you will get the equation as three x minus 6y plus 8z plus 6 equal to 0. And you can go for radical plane of S1, S4, subtracting which you will get that so after doing with S1, you can take any other things. So let us take S3, S4. You can take S2, S4 also. That is also okay. I have taken S3, S4. So if you separate them, you will get the equation as so these are nothing but the 4 radical planes. So if you want to write radical lines, so if you fix that 3 spheres S1, S2 and S3, for the 3 spheres, what are the respective radical planes? It involves S1, S2, so we will take this. It involves S1, S3, so we take this. So if you write the two equations together, this is nothing but the radical plane. Sorry, the radical line. So intersection of radical planes is nothing but the radical line. So you are representing the line equation in unsymmetric form. Our interest is to calculate radical center only, not the radical line. So the 4 equations, you need to solve them. So if you write it all together, and you can solve it by matrix form also. If you write the coefficients 1, minus 1, 1, and 3, minus 6, 8, 1, 0, 6, 2, minus 3, 7 of x, y, z equals to the coefficients minus 1, minus 6, minus 2, minus 4. If you have written them in the homogeneous matrix form, by solving that you will get xyz values. Or you can simply separate the equations from one another. You can reduce the variables and you will get the final point as minus 1 by 5, 1 by 2 and minus 3 by 10. It is justly simply solving the equations. Nothing else is there. I think you got the logic how to solve radical center. I hope in the previous papers also one question is posed on this model. Calculate the radical center for the spheres. A question was asked earlier. Okay. So after noting that, you tell, I will take the other concepts. The problems on the orthogonal spheres, etc. So any questions to anyone with regard to the approach, how you have taken this pattern? So go with solving the equations and confirm me whether you have achieved with this point or not. Or you can do the substitution method also. So from the first equation, x is equal to y minus z minus 1. So you substitute y minus z minus 1 in the remaining two equations so that you can calculate the point. So you will have an equation y and z terms only. By solving them, you will get the values. That also you can do. The simple reduction. So can I proceed with the next concept? So here is the problem. Find the equation of the sphere through a circle and cutting the sphere orthogonally. This is the problem. Please take a note of that. Right. Now, on reading the question tag, can you specify what formula we have to use here from the first line of the problem? Since you need to calculate the sphere equation through a circle, so let us exactly s plus lambda pi equal to 0, we have to use that. So for a small visualization, we can have the picture like that. Let us say this is our required sphere. So it has two properties. One property is it contains the circle. The other property is it intersects the given sphere orthogonally. This is the other sphere. It is intersecting this sphere orthogonally. So whenever you say a sphere passing through a circle, obviously we make use of the formula s plus lambda pi equal to 0. That is by default. So applying that formula to these values, you get that now if you take the coefficients as common, so why I have taken the coefficients as common? Because whenever two spheres intersect orthogonally, the condition we have to use is 2 into u1 u2 plus V1 V2 plus W1 W2 is equal to D1 plus D2. Or if you have written that U dash V dash W dash is equal to D plus D dash, where D1 and D2 are nothing but the constants in the spheres. So this is one sphere in the problem given there. So if you take the coefficients U, V, W and D, so U is equal to 1, say U1 is equal to 1, V1 is equal to 2, W1 is equal to minus 3, D1 is equal to 11. This is the other sphere which is the required one. These two are intersecting. So in this sphere also, if you calculate the values of U, V, W, D, so U2 is equal to 3 minus 4 lambda by 2, V2 is equal to minus 4 plus 5 lambda by 2, and sorry, U2 is equal to minus 2, this is, say this is V2, this is W2, and U2 is equal to minus 2 plus 3 lambda by 2, and constant dt is equal to 6 minus 15 lambda. So if you substitute the values in this one, since all the denominator values contain 2 gets cancelled here. So substituting here, you will get the value of lambda as minus 1 by 5. It is nothing but simply minus 2 plus 3 lambda into 1 plus 3 minus 4 lambda into 2 plus 5 lambda minus 4 into minus 3 is equal to 11 plus 6 minus 15 lambda. This is substitution you have to do. So which gives that the simplification lambda is equal to minus 1 by 5. So you please check that. So if you are doing simultaneously, do the problem and confirm the lambda value. And substituting lambda value here, you will get the required speed equation. However, the answer is not that much important. The thing is, what the pattern or approach we are actually following here. So here the thing is, you are applying s plus lambda pi equal to 0 for the circle, and the next sphere which is given in the problem, you are applying the condition that the spheres are orthogonal, so you are applying that condition, which determines the required lambda value. So after completing that, you please tell. Now I want to take one more problem here on this orthogonal spheres concept. This problem is given in the previous papers also, the model. And then we conclude our today's session. Tomorrow I want to take one more session on spheres. There we conclude the entire chapter of spheres. So tomorrow will be the last session for spheres. Later on, if you have any other doubts, you can ask. We will take the doubt clarifying sessions as per your needs. In the meanwhile, I try to bring an assignment so that you will enjoy that, having good knowledge about the spheres part. Okay? Now I erase this concept. So this is the problem. Which touch the plane at the point one minus 2 1 and cuts orthogonally the sphere. So this model is somewhat interesting. You take a note of that. After noting, please tell. So is it noted? So let us take that this is our required sphere. Now if you look at the problem data, it was given that it touches the plane. So let us say that if this touches the plane. At the point 1 minus 2 1, and the other part is it is cutting another sphere orthogonally. So this is the rough visualization. Clear to all? Now, in order to write the sphere equation, the basic thing is I must know what is the center and what is the radius. If you want to write the equation of a sphere, you should know what is its center and what is its radius. Now, my approach towards this problem is let me take this is the center. So, since it is touching here, distance is equal to radius, and also this line is perpendicular to the plane. So I will write the line of distance. By writing the line equation, I will know what is the center. By making distance is equal to radius, I get the parameter value. Is it clear to you what I said? Now, I am considering the radius which is perpendicular to the plane. And before that, a small sphere equation is given to us. Let us calculate its center and radius. Its center is nothing but 2 minus 3 0, and if you calculate the radius, it is nothing but 3. Because we are going to determine the orthogonality condition, there we have to make use of these two values. Now if you write the distance line here, it is nothing but x minus 1 by 3 is equal to y plus 2 by 2 is equal to z minus 1 by minus 1 is equal to r. So any point on the distance line will be of the same form. So by writing it, you have x is equal to 3r plus 1, y is equal to 2r minus 2, and z is equal to minus r plus 1. So every coordinate on that line segment will be of the form for a particular r. If you take that this is the center, center also will be of the same form. Okay? Are you clear all? Right. Since it is touching, distance between the 2 points is nothing but radius. So if you calculate the distance between these 2 points, it is nothing but radius of the sphere. So this is 1 point and this is 1 point. If you apply the formula, so it is nothing but radius is equal to square root of 3r plus 1 minus 1 whole square plus 2r minus 2 plus 2 whole square plus minus r plus 1 minus 1 whole square. So which is giving that root of 14 r square. Now let us use the final condition to determine r. Since the two spheres are intersecting orthogonally, the general thing is distance between centers is equal to radius square plus radius square. So this is one center of the sphere, this is the other center of the sphere. So you have 3r plus 1 minus 2 whole square plus 2r minus 2 plus 3 whole square plus minus r plus 1 whole square is equal to, here radius square is 9, that means 3 whole square, here it is nothing but 14 r square. So simplifying which, it will give us r is equal to minus 3 by 2. Substituting r value, you will get the center as the point, so minus 7 by 2 minus 5 by 2, and radius is nothing but 3 root 14 by 2. Now please understand, whenever center and radius are given, you can write the sphere equation using the formula that x minus x1 whole square plus y minus y1 whole square plus z minus z1 whole square equal to r square. So here we simply substitute the values, there is no need to simplify. So if time permits, we can simplify, otherwise it is somewhat a lengthy procedure. you have written the distance line, you calculated center and radius. So radius is nothing but distance. Then using the orthogonality condition, distance between centers whole square is equal to radius square plus radius square. Then by doing the simplification part, you will get R. Again, if you want to expand by substituting this 7 by 2, 5 by 2, etc., it will take much time. So apart from this, you simply substitute the values and conclude that this is the solution. It is enough. That we do actually. Okay. So please check with the approach. If any other queries you have, you can ask. Otherwise, let us wind up our today's session here, and we meet tomorrow with the last concept of spheres. So here, this equation, we use it to calculate the sphere equation when center and radius are given, isn't it? So this is the center of the required sphere and this is the radius of the sphere. So what I am saying is, you simply write like this. Is equal to some number you will get, right? So don't simplify this one using a plus b whole square, etc., because it takes a little time. Since you have evaluated center and radius, by substituting this, you will get the respective sphere equation. You are done. So if you simplify the total thing, the resultant answer will come as x square plus y square plus z square plus 7x plus 10y minus 5z plus 12 equal to 0. So depending upon the weightage of the question, you do. If it is just given for 12 marks, there is no need to simplify. If it is given for 15 marks, then you evaluate the expansion and get the respective answer. It's correct. So is the overall approach clear to all? How to solve this problem?